Ganesh, welcome to the podcast. It is a pleasure to have you join me here today.
Ari, the pleasure is all mine. Super excited to be here. I think this is the second time on. Yeah, let's talk blockchains.
hmm So I think to really lay down the groundwork, we should just lay down a very basic of understanding of how blockchain data works or how data works generally. So I think when it comes to blockchain, people think computer science, and that's in fact correct. We're talking about decentralized consensus. We're talking about encryption techniques through cryptography. And so this is a lot of new terminology and a lot of new ideas. So I guess we can begin by laying out the groundwork of really what makes blockchain data different from other types of data that people might work with, and how should we think about a blockchain and the data that is written down for it.
Absolutely. Maybe why don't I take a different turn here and start with an analogy? And perhaps the closest analogy would be the shipping and logistics industry. So you have goods that are manufactured in, let's say, in China, and those goods have to be shipped over to, say, like North America. Maybe you need to process the wood, maybe you need to mold the plastic, and then the goods continue to get shipped to the destination. So this is essentially how the pipeline of the shipping industry works. So data works the same way. So you have places where data is generated. That could be from user transaction, could be from machine transactions, whatever that nature is. And then the data needs to be transported to a place where the data needs to be consumed. Sometimes the consumption and the production happens on site, so in the same place. Sometimes it's not, and there are multiple downstream services that require the consumption of data. Generally, in all of computing is about 60, 70 years old now, right? Like digital computers. The reading and the processing of data is roughly 10 times compared to the writing of data. So for every unit of computation that is used to write data, 10 times as much is used in processing and analyzing and understanding and all the downstream services. So historically, there's been this industry called business intelligence that understands this transaction data and is able to gather insights from this. And you're using that to make it basically like predictive and predictive analytics or just make use it in decision making. So think of it, the closest way is a person in the cockpit of an airplane, and they have all of these dials that's consuming all of the data that's from the engines, from the gas tank, from maybe the temperature, the pressure in the cabin, and they're able to assess all of this information and make decisions on the fly without having to go to different places and gather the measurements. So maybe I botched up this analogy, but essentially that's the point I'm trying to make is there's data production, data consumption, and there's a transportation layer, and the data has to be transported, and there's lots of mutations, lots of like transformations that happen in the interim, and that's how you should understand data regardless of blockchain. So this like blockchain, like it's not blockchain data that's something special. It's just data has been around for a very, very long time.
Yeah, and typically when I think about blockchain data, right, the majority of, at this point, the use case that justifies the use of a blockchain is financial transactions. So for example, if I send you $5 worth of Ethereum, that in fact is recorded on a blockchain, it's kept cryptographically secure through cryptographic techniques, and that anyone at any point in time can go ahead and verify that information as being true. And one of the big selling points of blockchain technology is that it's decentralized, so that there's not one or two or a small group of people that can change the history of transactions. Instead, people independently are running nodes, verifying the information. And so everyone is almost independently keeping track of their own record of transactions to make sure that everybody is on the same page on what constitutes the history of all previous transactions. And so when different blockchains exist, we have different records of financial transactions that are going on. And so I know that Covalent has indexed now hundreds of blockchains, or at least in the hundreds of blockchains. So why don't we go over at its basics, when we're dealing with blockchain data, what are we looking for? What are the components of it? And if we're trying to create a tool, such as the API that Covalent provides, what is some of the information that's really fundamental that exists within blockchain data?
Got it. Okay. So before I answer this question, there's another key piece of technology that we have to talk about, which is a ledgering technology.
Hmm.
And so you have to go back to the 15th century. This is how spice traders in Venice maintained their records. So prior to the ledger technology, essentially, if I were to buy a pound of spice from you, I would give you cash, and then I would have that barter transaction. And that's how all of this would work, which means I need to have cash on hand in order to make that purchase or do that transaction. And with the ledger, what is unique is that I don't need to have cash on hand. I can have a credit and debiting system. And so I can just tally the records, maybe end of the day, end of the week, end of the month, and make sure that all accounts are balanced. So that is a key piece of technology that's been around for like 500 plus years. So you don't really need to have cash on hand. And blockchains are immutable ledgers. That is a key aspect here. So you have credits and balances, or credits and debits from an account balance. And then you can reconcile all of this at the end of the day or at the end of the block time, whatever it is. And that's like another key piece of technology. So if I were to borrow some stables from you, the ledgers maintain that system of record. So that is like a key piece of technology. So when it comes to blockchain data itself, basically all of the energy over the last 10 years is that how can we increase the scalability of blockchains from a write throughput perspective? This is why every single blockchain, every single alt L1, they're called ETH killers or were called ETH killers. The only thing that they cared about is the transactions per second. How fast can we write data to the blockchain? That's what matters, right? But the overlooked aspect here is how fast can you read data from the blockchain? Or now the question is more acute. Is the data even available to read data from the blockchain? And so one of the misconceptions about a blockchain is that people think of it as a database, that it has a system of record of all of the transactions from the Genesis block, from like t equals 0. But that's actually not true. A blockchain is more like a billboard. So you post data on there, and then you wait for someone to challenge the posting of data, the transaction data, with an alternate view of the system, view of the universe. And then post-challenge window, the blockchain there's no need to hold on to that data. So we can just prune the data or eject that data. So that is, I think, another key wrench in the gears that messes up all of those data, blockchain data transaction. So I think that gives you a little bit of a picture on like what are the key problems. Why does Covalent even have to exist, right? What's the point? Like if all data is public, all data is immutable, you can just run a node and extract that data out. You can't. And there's a litany of reasons why that's not the case, right? So we can go into the specifics there, but I think I'm going to pause here.
Yeah, so one of the things that comes to mind is that there's different blockchains, and different blockchains have different consensus mechanisms. There's different scaling solutions for different blockchains. So one of the things that I think we should talk about is if in fact there's different consensus mechanisms, the way that data is stored or structured perhaps for blocks is different. Is that a meaningful difference when we're trying to find ways to query blockchain data?
It's a great question. So one of the core thesis elements for the founding of Covalent is that the world is diverse. And so I come from a database background. In the database world, there's literally over 800 databases. And there's actually a website called dbdb.io. So it's a database of databases. And 800 plus databases, it's unimaginable, like because people are diverse, needs are diverse, requirements are diverse. So you need key value stores, you need time series databases, you need relational databases, you need asset compliant databases, you need graph databases. And there's just so many different use cases. You can't have a one size fits all. And blockchains are exactly the same. You have blockchains for games that doesn't require such a heavy security requirement, doesn't require such a big security budget. Or you have blockchains for like the Bank of Canada or the federal government to settle the records that requires the highest level of security that's possible. So needs are on a spectrum, and you can't have a one size fits all. So what that means is that the trade-offs that these blockchains do in terms of scalability, in terms of security, in terms of usability, necessitates a unstructured, differentiated data model. So that's just the underlying problem, right? Or I wouldn't say it's a problem. That's just how the engineering is done. You can't really think about spinning it to a standard when top of mind for you is to just solve your critical transaction or writing needs. Like, what do you need to write this transaction as fast as possible?
Hmm.
Now, the downstream consumption of these blockchain data, they don't really care about the consensus algorithm, or they don't care if it's a POA or a POS. They don't care if it's like a sharded blockchain or if it's a roll up, or it doesn't matter. What they want to care about is what is the inventory, how much revenue have you made, who is delinquent in their payments. Those are the standard set of questions. And most people actually end up using Excel for all of these technologies. And
Hmm.
so the lesson from business intelligence over the last 30, 40 years is that enterprises, when they adopt a new database technology, because databases come out quite often, they don't necessarily change their downstream applications. They're not going to retrain the people. They're not going to reinvest in their tooling and their infrastructure. So they will keep all of that exactly the same and then just build or adopt a middleware that modifies the blockchain or the database data into a format that can be consumed by downstream applications. So that is a big lesson from the last couple of years. And there's lots of middleware companies that have existed since the 70s, right? So this is like it's not something that's brand new or novel. So
Hmm.
the key thing here is that the needs are different and therefore the data models are different. But the consumption side, there's a standard P&L, there's a standard income statement, there's a standard balance sheet, and there are norms on how to format this data and present it so that regulators, so that auditors, so that other stakeholders can consume this data, and that requires unification or standardization or normalization. So
Yeah.
none of this has to do with Covalent, but I'm just telling you how the landscape is.
Yeah. And I think that's no, I think all of those things are very important notes. And one of the things that comes to mind is talking about use cases of blockchain. So when I think blockchain and cryptocurrencies, besides Bitcoin, I think of trying to solve problems that require decentralized consensus, because then you have a agreed upon shared record of information. So if the shared record of information is obviously difficult to query and hence why we need services like Covalent, I'm wondering if you could speak to some of the consequences of that, of what that results in when adopting a blockchain for a specific use case. So, for example, if you are trying to use the blockchain to tokenize assets or tokenize stocks, basically, how is Covalent's job relevant to the use cases that are legitimate that blockchain may be able to provide in the real world?
So Covalent is just an enabler of these technologies, right? So it doesn't open up new kinds of use cases per se. So you have to go back and understand or ask the question, what is the point of a blockchain? And I think the blockchain has two primary, or the blockchain as a technology has two primary benefits. One is that it knows what the ground truth is, right? So people are not contorting the truth with their own personal biases or their opinions. So that is extremely important. I think we're seeing in society today that trust is at an all-time low with these big institutions.
Yeah.
You don't know what's going on with elections. You don't know what's going on with COVID. Some people said the vaccines are mandatory. Some people are now saying that the vaccines are. I never said that, right? So the truth kind of gets mutilated in some sorts, right? So the blockchain with the immutable ledger is the truth. You can mutate it. That's like the key aspect. The second point is that as a side effect of having the truth that is easily accessible, what happens is transaction costs are minimized. So right now, if I need to transact with you, let's say I do a real estate purchase, right? I buy a house from you. I need an appraisal. I need notary agent. I need a lawyer. I need a realtor. All of these guys, they dip into that transaction cost. They just
Yeah.
stack on, right? So that the transaction cost becomes so expensive. And now, if you just had a escrow that's a smart contract, and you had the two parties that are able to transact with each other, but rely on mathematics and cryptography for the security of that transaction, then suddenly the transaction data is minimized. So I think that is a super big benefit of like, or one of the big benefits of blockchains. So now the problem is, okay, so all of these blockchains have, kind of solving the throughput problems. So like Solana is able to write to the blockchain really fast.
Hmm.
Ethereum and the rollups are able to do it very, very fast. But to fulfill the promise of blockchains, how are you going to read that data? So that is the key problem that Covalent solves. And so what we do with all of our products is make blockchain data accessible.
Hmm.
So in theory, blockchain data is public, but there's a variety of differences between the different blockchains. As I previously mentioned, these changes are necessary to fulfill their throughput requirements or the security requirements. But for a person who is actually trying to consume the data, that those things don't matter, right? It's a different set of different decision point. And so what we've been able to do with Covalent is basically scrape all of this on-chain data and then normalize that to a canonical schema. So it's one schema across these 200 plus blockchains that we support. And then that schema is then used through any downstream products. This could be the API. So if you're a developer, you can programmatically access that data through an API. API stands for Application Programming Interface. It's how developers interact with other systems. Or we have a product called Increment, which is like a dashboarding product. So if you want to show a chart on your P&L or how much money you've made, whatever transaction you have on the blockchain, you can use that. We have a block explorer product called Gold Rush, and we'll have more products in the future. So these are all different use cases. So think of it as the same set of ingredients but multiple recipes. So that's really the kind of like system that we've built.
I imagine that the need for services such as Covalent is tremendous as the fragmentation in the industry continues to grow. Because if we compare to previous years, or let's say a 5 to 10 year period versus in the most recent 5 years, I mean, the number of infrastructure investments that venture capital firms have made the past few years is enormous. In layer twos, if you look at social media, you see another L2 being announced every other week, it feels like. And so it appears to me that there's a lot of fragmentation, which means that there's a whole bunch of now data that needs to be standardized across the board that can then go downstream to be used for the applications. So why don't we go through a couple like use cases of actually using, let's say, Covalent's API, which again, for our listeners, we can think about an API as connecting to some other form of information, let's say. So we can use Covalent's API to access some blockchain data that we can use for an application. So maybe we can go through some very cool applications in DeFi or wherever that has used Covalent.
Absolutely. So the Covalent API is organized as a set of endpoints. And so let me talk about these bundles of endpoints that we have. One is for balances, so mostly around token balances. One is for transactions. One is for NFTs. One is a set of security endpoints. So let's take these four endpoints. So with balances, you're basically able to visually render the ledger. So what is the outstanding balance of all of the different accounts that we have? What is the transfer of these tokens in and out? So the standard tokens are ERC20 tokens on the blockchain, if you're an EVM-based blockchain. So, RE received 1,000 USDC at this point, and RE also received 1,000, CQT at this point, and the price of CQT at this point was, let's say, 20 cents. So it's that entire ledger. And if you add up the credits and debits, which is basically the incoming funds and the outgoing funds, that's the token balance at the end, right? So that's really how the ledger works. And if you have any kind of like interest-bearing kind of assets, that's a second balance, a second account. So you don't mix up the initial principal with the interest. So the blockchain makes all of this really, really seamless. It's all transparent. It's all in different ledgers on the blockchain. And so the set of balances endpoint lets you render that entire, ledger, basically. So the second set of endpoints are transactions. So transfer of assets is not the only kind of transaction. There can be lots of transactions. There could be creating a safe, deploying a contract, destroying a contract. Of course, purchasing an NFT is like moving the ledger, right? Or you're touching a couple of like account balances. But transactions are more generic, right? And transfer transactions are just one kind of transaction. So this is giving you the full set of transactions that mutate the ledger. So the ledger is maintained outside. The transfer and the balances give you the direct access to the ledger, but the transactions mutate multiple accounts and multiple ledgers. So there's a set of transaction endpoints. Then we have the whole set of NFT endpoints. Now, NFTs are a pretty big deal with the face profile pictures. It used to be really hot in 2021, and basically every celebrity was had an NFT. I think Tom Brady also had an NFT at some point. Jay-Z had an NFT. I think they're coming back in some form through these meme tokens. I'm not sure where it's going to go. I think it's still early to say. But what these NFTs are is a set of like 10,000 images or assets, some kind of visual asset that falls under a collection. So with these NFT endpoints, you want to understand what is the balance of these NFTs that you have. What is the floor price of this collection? If you have the actual asset, you want to render the asset. Now, the assets on with NFTs are these gigantic images, right? They're not optimized for rendering on mobile, for example. So what we have done is we've downloaded, I think over 200 million assets and thumbnail them, resize them, and then create snapshots from videos. So if you're trying to render your NFTs on your phone, you're not downloading 10 megabyte images just to render a small thumbnail. So it really helps with those. And the security set of endpoints is like to manage with approvals and so on. So those are kind of the set of endpoints. So now if you use these building blocks, you can build really interesting applications. So if you think of a wallet, so think of MetaMask or think of Rainbow or think of Rabby or any of these wallets,
Mhm.
there's four screens that are super important. The first screen is your list of balances. So you connect to a blockchain and tells you this is your balance of USDC, this is your balance of CKT, this is your balance of like any other token, right? So rendering that, you just hit the balance endpoint. That's one call and it renders all of your balances. The
Mhm.
second thing is list of all of your transactions. So you see all of your transactions. And the third thing is your list of NFTs. People want NFTs to be separate from your token balances because token balances are typically financial
Yeah.
and NFTs are sometimes audio, they're collectible, they're art, all kinds of things. So they want a different view for that. So we have the NFT endpoints to render that, right? And going back to the balances, when you see a list of balances, when you tap on one of those token balances, it gives you the full transfer history, the ins and outs, and the price, the historical price at the time of the transaction. So that's the transfer endpoint. So you can put all these pieces together and then create a full wallet application. So we have templates here. This is with Gold Rush. Gold Rush is like a modular block explorer. So if you want to create a wallet application, for example, then you just go and fork that repo. It's all open source,
Mhm.
and within I would say a day, you would have a fully functioning wallet application, and then you can start to build differentiating features. So just like how I explained the wallet interface, you have NFT galleries. So in NFT gallery, you have any collection. You have a list of all the tokens. You can click on any of the token. You can see the sales history. You can see the floor price. You can see the active bids and sells and so on. As long as the data is on chain, Covalent has access to the data and is able to offer through this APIs. So that's basically how, there's thousands of applications that are live on Covalent today, 3,000 plus by my last count.
Mhm.
And so they're mostly like taxation tools, wallets, NFT portfolio tools. We're starting to see more like account abstraction kind of stuff. A lot of the safes use Covalent, the Gnosis safe products. So yeah, so it's just a set of building blocks to build applications.
I mean, just the idea itself of having a transparent ledger that anybody could look at any time that has a record of all the transactions, all the prices of a token at that time of that transaction, something very easy to use. And all of a sudden, I think taxation becomes a lot easier because I think that currently Web3 as it exists today, all having a MetaMask wallet, for example, which is the way of accessing the blockchain, the way of storing your cryptocurrencies, or rather storing your password to your cryptocurrencies, we can think of it as. Um, this is all completely foreign to individuals who are involved in traditional financial services. Even when talking to my friends, for example, and I mentioned the use of my wallet, they have no idea what I'm actually talking about. So I think that if we change our perspective, or rather, if individuals change their perspective and they say, well, this is a much easier way to keep track of information that I don't have to trust the individual providing that information to be true. It's already on a decentralized ledger. Then in fact, all the record keeping becomes a lot simpler because you simply have to show your address, for example, prove your pseudo anonymous address in fact belongs to your identity, and then it allows you to provide all the information that you would like to provide. So let's talk about AI, artificial intelligence. So I had the opportunity to enroll in a machine learning course for the past few months in my master's degree, where I learned a lot about large language models, supervised and unsupervised learning, and it's not as maybe exciting as those might make it out to be who are selling some token or some sort. It's very complicated and it's very difficult to understand. So let's talk about the role of AI in relationship to blockchain data. So what is Covalent working on in this respect? What are you thinking about in terms of AI and blockchain?
Great question. I think AI is top of mind for a lot of people in the industry. You can see NVIDIA's stock and just the excitement and the number of startups that have raised capital in the AI space. So, where specifically, to answer this question, there's two aspects. One is where is AI going, and in a macro setting, and how can crypto help with that? So, with AI, you talk about decentralized AI, right? And that can mean many things. So, what is often overlooked is decentralized data for AI. So, when people talk about AI, they talk about decentralized compute, which is the training, and decentralized inference, which is the query of these LLMs. And there are lots of projects out there that do one or both or together, right?
Mm-hmm.
And essentially, an example would be with someone like Akash, who has this access to GPUs. So you can rent out your GPU on the Akash network. And if you have a training or inference problem, you can submit it to the network and you can use someone's GPU you can rent someone's GPU to do your work. So that's an example of where it's like an Uber or Airbnb for GPUs, right? So that's super interesting. Now, the key aspect here is what are you feeding into these LLMs for the training and the inference? And that's where the decentralized data and that's where Covalent's thesis comes in. So it's almost like you can't expect good results in the gym if your diet is crap, right? Mm-hmm. It's like what did it say? The summer bod is built in the kitchen, right? So similar to that, the state-of-the-art language models are built with decentralized data. So now the big challenge with the data aspect is if you look how Facebook or Meta and all of these bigger companies are training the LLMs, is they have these RegTech teams that cleanse the LLMs before they're made public, because there might be some leakage or someone's bias embedded in that training parameter set. So that is a key problem that decentralized data, especially from something like Covalent, can help. Now, there's nothing wrong with people's opinions, right? I think that's just the First Amendment right, where you're able to freely express your opinion. And I think that's what makes the world an interesting place. But what is not correct is biasing the output of a system based on your personal biases without the disclosures, without the right disclosures. So this is where an immutable ledger, where the inputs and every transformation, every bias, every mutation of the data is stored, helps in tracing back the provenance of that data. Another analogy to think about this is if you look at champagne and sparkling wine, it's only sparkling wine from the Champagne region that can be called champagne. Otherwise, it's called just regular sparkling wine. Mm-hmm. And I think at some point, consumers will start to demand what is the source of the training data, and does it come from a decentralized source or not? I think the decentralized training and inference helps reduce the cost and makes it more accessible. But the data aspect is super important, because the last thing you want is someone to make a decision from an LLM that was trained with the wrong kind of biases or had some foreign actor who mutated the data set, and then it leads to a big societal mess.
So the information being decentralized itself doesn't actually change whether or not the model produces outputs that are biased or not, but it just increases the transparency because you can trace back the information without worrying about people manipulating where the data comes from. Is that correct? Or is there something else to it?
That is exactly correct. So I think, at least my personal opinion, is that people should have a right to voice their concerns, their opinions, and that should be expressed. But what is not correct is having these biases hidden, right? Mm-hmm. And having an ulterior or a hidden agenda. So that's where the blockchain helps, where it discloses all of this changes that have been made to the ground truth.
I want to ask you about the importance of projects being public goods. Okay, because I know Covalent strives to be a public good. One of the things I think is the future of the web are decentralized, or in some aspects, technologies or applications that are decentralized. So, in other words, there's not small meddling behind the scenes going on, and it's more dispersed in terms of who has control over these applications. So I want to know like what your thoughts are generally on the importance of making public goods, how you try to make Covalent be part of this process.
See, it's a very interesting question, and it goes back to the history of open source, right? And if you look over the last 20 years or so with open source, the first set of open source models were these service businesses. This would be someone like Red Hat that recently got acquired by IBM for, I think, a lot of money. But what Red Hat did was it had this open source Linux distribution. And the way they monetize that is by providing additional services on top. So it's mostly a service business. And the software itself was free. They were not charging for the software, and they went public. So they're a pretty successful at scale kind of company. And the service business does have its shortcomings. It's not as scalable as a pure technology, pure software, pure play software company.
Mm-hmm.
And with the software, what happened is like the V2 of open source. And this would be an Elasticsearch or MongoDB, open source like Kafka, which is Confluent. And so there's this open source or even GitLab. There's this open source piece of software, but there's a commercial company behind that that helps with the hosting and so on. So all of these companies I mentioned, Mongo, Elastic, GitLab, Confluent, they're all public companies. They're all like over $200 million in revenue a year and growing pretty attractively. So they're like pretty good. Now, there are some gotchas with that. So I think the third iteration of open source are these open networks that continue to produce these public goods. So this is where crypto networks come in. So you not only have the software that's open source, so all of Covalent's like software is open source.
Mm-hmm.
And the whole stack is open source. The node itself is open source. Everything is like open source, but the hosting itself is also decentralized. So now the public good is not just the software, but also on how the software is run. So it's not a centralized company
Mm-hmm.
that owns and hosts this software. So that is, I think, a key kind of difference. And I would say it's an evolution of open source itself.
Mm-hmm.
And that's quite exciting. So with Covalent, for example, there is an equity company that has never taken on external investors. It's a Canadian company. And this Canadian company builds the software. And the software is then run by these distributed operators who are all independent, right? And so the Covalent company that builds the software has very little say in what's happening with the network itself, because it only runs one out of the 30 nodes that's available out there, right?
Mm-hmm.
So that's really how I think how open source and these public goods have evolved. And with public goods, generally there is this tragedy of commons where everyone is leeching off the public good and has no incentive to return back. And I think this open source or this distributed hosting model really helps with that, because they help govern and shepherd and steward the software in itself so
Mm-hmm.
that it's for the betterment of the public good and society at large.
Mm-hmm. So recently, with my university, I've been researching DAOs and decentralization. And so one of the questions we sought out to answer was, if we look at a given decentralized application, what is the Gini coefficient? What is the number of people that's required to get 51% of the voting power and try to manipulate that decentralized autonomous organization? And one of the things we came across which is almost all the major DAOs, if you look at applications that have a DAO, that have a treasury, that DAO manages that treasury, it's like the number of people required to achieve 50% is 3, 5, 7, 2. So one of the things I'm thinking about is the nature of decentralization and open source, and how blockchain can solve that problem, encourage participation in governance, because I think lack of participation in governance is a very difficult problem that we haven't been, as an industry, solving very well, right? And it's going to be interesting to see how that works out, if participation in actual ecosystems, because as you exactly mentioned, it's very hard to get people to contribute to these open source projects, even to the smallest degree of making votes, doesn't actually have any fees associated with it at this point, not like years ago. And yet we're seeing this lack of participation exist. And so I think it's going to be interesting to see how this plays out long term. And especially as you mentioned, the number of projects and tokens that exist still after so many years that really don't have a legitimate use case in using blockchain technology, I would say. I mean, potentially, even gaming itself, there's very compelling arguments to be made on both sides for use cases of blockchain or lack of use cases for blockchain. So I think it's a tricky thing to look into. When you think about the next few years, when you think about data, where things are going, big banks coming in, ETFs being announced in the US, what are some of the things that like you like to keep in the back of your head, or trends, stuff like that that you like to think about?
Absolutely. So I would say there is a economic kind of roadmap. There's a technical roadmap, and there's the whole like governance and the regulatory roadmap for the adoption of these technologies. On a technical basis, I'm really excited by all of the throughput initiatives that have gone live in the last maybe 6 months to a year. So this is mostly the DA solutions. This is Celestia and EigenDA being live today. The Dekun upgrade going in. I think the next upgrade is being planned out. So all of this just increases the scalability of these systems. So that's super, super exciting.
Hmm.
The regulatory stuff is really incredible because I think if you were to have a regime change in the US, that is from what it looks like. I'm not American. This is what I have looking outside in. Is Trump is more pro crypto, and so if Trump were to come back, I think there'll be lots of excitement in the industry, and so that's something to look forward to. The ETFs, what has happened is that is basically mainstream adoption of the financialization of these products, right?
Hmm.
Now it's questionable if it's going to have the same impact with the Bitcoin ETF as opposed to Ethereum ETF, because the Bitcoin ETF, it's very clear this is a digital gold, it's a replacement for gold, and a very clear kind of product market fit. But Ethereum ETH itself is a gas for applications. Now you need to dig deeper. What are these applications? Where are the
Yeah.
revenue streams? How concentrated is the revenue? How defensible is revenue? It's a little like it's not so straightforward. So I think there's something that needs to be, I would say, the market needs to understand and appreciate what Ethereum has to offer or ETH has to offer, and maybe the ETF will help quell some of those doubts. And so stable coins being adopted, that's pretty huge, right? So I think those things are really, something you can look forward to. And then just on the economic front, I think use cases are really encouraging. So you see the real world assets are RWA. So the founder of Compound started a RWA project. So that's bringing T-bills onto the blockchain. So that's like, a really cool kind of use case. I think they recently crossed $100 million in deposits. I would say all other kinds of like RWAs are pretty exciting. These meme coins are pretty interesting because, if you look at the traditional finance, I think a lot of societies become more prone to gambling. If you see the growth of these 0 day options, they're very popular these days. So, just people are more open to these technologies just overall. So I think that's a very positive sign. I'm not sure where all of that is going to lead, but on the Covalent side, we're a horizontal platform. It doesn't matter where the use cases are. We will support all use cases. We're not locked into one specific use case.
Hmm. It's I think I definitely agree with the fact that the amount of betting and gambling I think has grown. I can't remember seeing as many advertisements about sports betting both on TV and elsewhere than I did before. The number of people that participate in sports betting is it's significant. And if you look at the advertisements, like even in gaming, in other industries, sporting events, there's just a tremendous amount of gambling that goes on. Unfortunately, I wish that cryptocurrencies didn't invite as much get rich quick as it did. And perhaps people would be better off reading the Bitcoin white paper before reading the website of a meme coin. I think that would do people better. But unfortunately, I think the documentation is a little bit more challenging to understand than price goes up, you have more money in your account. I think that's much easier to understand. Um,
It's why we have this periodic bear markets to flush out the swamp, right?
Yeah, the speculators. One of the things in one of the videos I made recently, I was discussing why Bitcoin has the price it does, or what makes Bitcoin valuable. And one of the things that I recognize is that Bitcoin is not meant to be a speculative asset. It's not designed to be a speculative asset. Just because people happen to speculate on it as they do significantly doesn't mean what it's designed to do. And I think people frequently, especially people who just never know anything about Bitcoin, they think it's strictly a speculative asset, something that you can make money or lose money on investing in. But it has nothing to do with the underlying asset represents. It represents a peer-to-peer cash system, which is not at all trying to get rich quick. It's meant to solve a problem of allowing small transactions to occur without the use of intermediaries. So it's strange. I find it that people still have no idea what Bitcoin is, cryptocurrencies are generally speaking. And I think that the potential is there for it to really make some differences in the real world. And I think Covalent's doing an amazing job of that. I mean, I haven't used the API yet, but I'm excited to use the API. I've been building a little bit of an application with my friend the last few months, getting familiar with smart contracts. I learned so much about how relevant smart contracts are to potentially replace lawyers. I don't know if you have any
Yeah.
thoughts on that, but I frequently think about computer scientists being the next lawyers of the world.
No, it's huge. Like, something as simple as an escrow contract or a vesting contract, which requires an army of lawyers to like understand, and it's so much work. Right now, we have a vesting contract on chain, and you can just go look at Etherscan and see what the vesting schedule is. Everyone can see it. There's no confusion. There's no PDF that you need to look up. It's literally just on the blockchain. So it's so much simpler. I would say even transacting with escrow is so much simpler. Before we have to like have a third party and pay them a fee and make sure they're like it's all coordinated. Right now, I just push it into an escrow contract. It's all asynchronous. I can do it at my whenever I'm free, and the other person is only able to, send it through if I send it when the counter transaction happens. So these things are game changers. I think once you start using this. Also, streaming tokens, streaming technology, incredible. I can pay you every block. That's incredible. Right now, the whole financial system, like if you look at payroll, it happens every 2 weeks, and so we're
Mhm.
giving a interest-free loan to the company for for 2 weeks, and then the taxes that are withholding taxes, we're giving an interest-free loan to the government for a year. That's a
Yeah.
lot. Like that's 5.5%. And so with streaming technologies like I think Streamflow and there's a couple more, literally you get paid every block. So that's incredible. Like I think these things are game changers.
Yeah, that sounds super exciting. I mean, one of the things I frequently think about, or rather, like one of the things I had an issue was when I had to open up. So I moved to Portugal and I had from Canada and I had to open up a Portuguese bank account. I had to transfer funds, and it's a huge headache. It's really a huge headache. You have to bring your contract. You need to bring a legitimate identification. It doesn't take 1 minute to open up a bank account. Let's just say it takes a serious amount of time. Like even the availability of 24-hour crypto accounts through MetaMask or whatever wallet provider you use is tremendous. And then I just had to open my computer in Portugal, and all of a sudden my funds were on my computer, and I didn't have to do all the headaches. Anyways, it's really exciting about the use cases that might come to the mainstream. Last question here, Ganesh. Do you have anything else you want to share? Some interesting things going on in the roadmap, some awesome accomplishments that Covalent has had the past few years you would like to share?
Yeah, I think we're a team that continues to ship, right? So no matter if it rains or shines, we will ship, and we've been doing that consistently over the last 5+ years. And so over the last couple of weeks, we had a staking migration back to Ethereum, so that was pretty massive. So people are really excited about that. We have a big announcement that's going to drop next week. We're going through a major brand refresh that is happening. I think in 2 or 3 weeks. That's like we're changing all the economic and the technical aspects of Covalent itself. We have the Ethereum Wayback Machine. The testnet for that is going to be launching. We have light clients that are launching right now to participate in the Covalent network. You have to be it's mostly like it's very heavy duty, so you need to be a dedicated operator with dedicated hardware. And so you have this, we're calling them Olympic light clients. It's a way for 10,000 people to participate in the Covalent validation service.
Hmm,
You can run it on your phone, you can run it on a laptop. So that's super exciting. You can have
nice.
a whole like lore around it. So there's a lot to do, just a lot. Besides just the API also has crazy amount of features coming down, right? But the core infrastructure itself is like we're just building, 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 building. So yeah, so just stay tuned with all of our socials.
Amazing. Amazing. Okay, Ganesh, thanks so much for joining me on the podcast, talking about your experience, Covalent. It was a great pleasure.
Ari, the pleasure is all mine. Thank you so much for having me here.
Thank you.
Take care. Bye.